So this is video 8. So let's start from the statistical error. What are the types of statistical error? So type 1 and type 2 errors. So again, if you remember in the basic definition we have discussed according to the prof. So type 1 errors are that the null hypothesis is true, but we falsely reject it. So there is no true data results, but we are cooking it. And type 2 error is and the type 1 error is prevented by eliminating the bias and confounding factors. And type 2 error, what my concept is that according to the prof, that actually there is a difference in the outcome, but but due to the type 2 error we are falsely presenting it. So what is the definition? So what is meant by type 1 error? Null hypothesis is actually true, but is accidentally rejected. The rate of type of error usually equals the significance level of the test. At 5% significance level, the investigator accepts that 1 in 20 tests will result in an erroneous rejection of null hypothesis. What is meant by type 2 error? And type 2 error is when the null hypothesis is false, that there is actually the difference, but is not rejected, is accepted. So type 2 errors occur when we fail to recognize the truth. However, a statistical test can never prove the null hypothesis to be true. What is type 3 error? Again, I don't want to learn. How can you avoid type 1 error? Very good question. Reducing the amount of acceptable error reduces the chance of type 1 error. Reducing the amount of acceptable error. Errors tend to be viewed as a more serious than type 1 error and thus more important to avoid. In practice, reducing the chance of type 1 error means reducing the level at which significance is assumed from 5 to 1% lower. Reducing the risk of type 1 error doesn't involve a converse increase in the risk of type 2 error. So subgroup analysis. What is a subgroup analysis? Subgroup analysis is the term that is applied to searching for a pattern within a subset of subjects in a study. It may be encountered in every study design, but it tends to be seen most frequently in large randomized trials. So how would you assess the quality of a subgroup analysis? Again, DARA, design analysis, reporting, and applicability. What problems can you think of with subgroup analysis? I don't want to learn the subgroup analysis. Let's go to survival analysis. So again, this is something which I wasn't aware, and during this course, one of the consultant told me what is Kaplan-Meier curve. So what is a survival analysis? So survival analysis is a branch of statistics which consider comparisons of time to event data. Time to event data. It can be applied to any event, but is frequently encountered in the analysis of the time to death or recurrence in the cancer patients. The analysis depends on the well-defined events occurring at specific times. Generally, survival analysis can only be applied to the events which only occur once. What is censoring? Censoring is a technique used in the survival analysis to account for missing data. If the occurrence of the event of the interest is not known for a particular participant in the analysis, his or her data are censored at the date of the last contact. What is the Kaplan-Meier curve? This is a graphical representation of the survival analysis. So Kaplan-Meier curve is a form of survival analysis widely used in the medical research. It can be used to measure the fraction of patients living in a certain time following the treatment. It may also be used to measure the time to the development of particular study endpoints such as disease recurrence or progression-free survival or progression. A key advantage is that the technique can take account of patients who are censored due to loss to the follow-up. By convention, censored patients are indicated by a tick on the plot on the time. Again, not for us. How do you compare two Kaplan-Meier curves? The curves are often compared using the log rank test. This is not an parametric test, which is used when the data are skewed. Often the case is survival data and when some data are censored. If there are no censored data, the Wilcoxon rank sum test can be used as an alternative. The test involves computing the expected and observed events in each group at each observed event time. The log rank test gives equal weight to each event regardless of when it happened. The Pareto test applies a greater weighting to the earlier events. What information should be presented with Kaplan-Meier curve to allow adequate interpretation? Definition of patients, T-stage, treatment groups, and study groups with the dates of enrollment, the actual number of patients in each group at the start of analysis, together with the revised number at the reasonable time interval along the curve. These numbers should be presented with 95% CI. Definition of event and censoring, median follow-up time and method of calculation, numbers of missing data and losses to follow up in each group, together with the information on how these issues are handled, results of a test statistics. How far should the plot extend? Theoretically, the plot can extend as far as the point of contact with the last patient, but this results in wide confidence intervals and consequently much uncertainty at the far right of the plot due to the small numbers. Conventionally, the plot should be curtailed when less than 20% of the patients remain under follow-up. So thank you very much.